In the previous video, we talked about the if keyword and then went into more detail about the code block, and we also talked about some of the issues with code blocks and duplication of code. So what we're going to do in this video is talk about methods, which is a better way of ensuring that your code isn't duplicated and also makes your code a lot easier to maintain. So I'm going to make a bit of space here. And what I'm going to do is I'm going to paste the code that we used in the previous video. And if you recall, it was this code, and then when we ran it, we got two final scores. So we got the score of 2,300 and 11,600. And of course, the big issue was, if you recall, I changed the code in one place in the first code block, but not in the second code block, showing you how easy it was to have errors because you've got duplication of code that is essentially doing the same thing. And it's just not really convenient. And if nothing else, it's actually more effort for you to have to create this code multiple times. A lot easier if we can create code once, put it in an area and use it time and time again. And that's what a method gives us. So let's have an attempt at creating a method now. Firstly, you may not be aware of this, but we've been using a method all along. This entire thing here, this entire section of code, that is actually a method. And the method has the name of main. And all the code in the middle of it is the statements that form the method. So if we want to execute the method main, this is what's going to be executed, all that code that's in there. So what we're going to do is we're going to create our own method. We're going to call it calculate score. So I'm going to put it down here underneath the last brace, and you can see that brace matches up with the public static void main. This is IntelliJ's way of saying that these two things line up. So we have to start our code for a new method outside of another method. You can't put a method within another method. They need to be outside of it. And also when you're creating a method, you don't want to put it too far down. We don't want to put it outside this public class definition. And we'll be talking more about that in future videos. It has to be within that area there. So this is where we would actually type it. So we're going to call our method calculate score. So we type it. We type public static void. I'm putting spaces between all of them. Calculate score. Now don't worry about public and static. We'll be talking about those a lot in the future. For now, just keep note that you need to actually specify and use the terms public and static when you're defining a new method, and void. So for the three terms here, the public, the static, and the void, all in lowercase and all separated by a space. Don't worry what they mean at the moment. We don't need to know that. We'll come back to that shortly. But they are all keywords, as we discussed in a previous video. The ones highlighted in blue are keywords, so they're part of the Java language. So what we need to do is put our code in between the braces. And anything that's in between the braces is a statement that is part of this method that we've called calculate score. And when we execute this method, and I'll show you how to do that shortly, all the code we put in here will be executed. So to do that, I'm going to copy this first portion of the code and I'm going to paste it in. So I've pasted it into our calculate score method. And now what we can do is from within the main method, we can call this method. So how do we do that? Well, firstly, we'll delete this part out because we don't need this now because it's actually going to occur in here. So to execute this calculate score method, we just type calculate score. You can see as I started typing, IntelliJ came up and said, oh, do you mean calculate score? If that's the one we want, you just press enter and just put it in there for us. And you also may not have noticed, but this was a light gray before the actual name, but now we put that in to turn to a black. And what that's saying is IntelliJ is saying, I can see that this method is being used now. So just to confirm, if I delete that, it goes to light gray again and it says it's never been used. So that's a handy way to know if you've got any methods that aren't being used in your programs. Check to see whether they're light gray in IntelliJ. But I'm going to put that code back. So what we've done now is we've actually said, when we get to this portion of the code, I want you to jump ahead and then run all this code. And once you get to the end, come back where you left off and then continue on from down here. So what should happen is it'll define the variables. It'll run this through once, and then it'll come through and run the second part for us. So let's try it out. We should get the same result. And you can see that it's worked quite nicely. So how would we do the second component? Well, we would normally have to create a second method to do this second part of the code. But of course, doing that would mean that we are effectively duplicating our work again. So we haven't really fixed anything. All we've really done would have been just to convert our two code blocks to two methods. So there must be a better way of doing that. Well, there actually is with methods, because we've only started to use the very basic components of methods. So if you think about it, so what we'd really want to do, what would be ideal would be is if we could pass this information, whether it was game over, the score, the level completed, and also the bonus, to pass this to the method so it doesn't have to create the variables, so they're sent to it and then it can actually work with those variables. Well, as it turns out, we can do that. We can actually pass information to a method. So what we need to do is we need to look in this bracket area and we need to define the parameters that are part of this. I'm just going to close this so we've got a bit more space. So what we need to do is tell the method, define in the method, what parameters or what information we're sending through to it from our main method, from where we're actually calling the method. So to do that, we just type in the type of the variable and then the name we want to use it. So we can type Boolean, game over. And we separate each variable that we want to pass, the type of information, with a comma. So the second one, we're going to put a score, which of course is an int, so it's int score. You notice how I'm not putting the value there, I'm only putting the data type and the name of the variable. And you'll understand why shortly why we're not putting the value. The third one was the level completed, also an int, level completed. The last one was a bonus, we're going to call it int bonus. So what we've done is we've now said this method now has to be sent 4 parameters, and then they are a Boolean and 3 ints. So you notice by doing that, first we've got errors here now, but we've also got an error up here now. So it's actually it's expecting 4 parameters, and these are the 4 parameters we've defined here, but it's actually saying, well, the arguments that you've actually sent, you haven't sent me any at all. So there's none at all, and that's why it's actually complaining. So the parameters is what we define in this section when we're setting up a new method. They're the parameters, but arguments are the actual values, not the data type and not the variable name, but the actual values that we want to send to the method. Now, so we'll come back to that in a second. So what we want to do here is we want to actually send the data by placing the arguments to the calculate score function. So how do we do that? We can type the values that we want. So we can actually just type true, 800. And just to confirm, if we go back and have a look, we've only typed 2 parameters. IntelliJ is saying, okay, you've got 2 there. I can see game over. The actual argument is set to true and score is set to 800. So they're going to be the values that match up as we call the method, but there's still 2 we need to finish off. And they are level completed. Noticing I'm putting a comma between them both, level completed and bonus. As soon as I enter the last one, we suddenly haven't got any errors anymore, because as far as IntelliJ is concerned, the actual arguments that we're passing match the parameters we've defined for the method. And this is really important. If you don't match those entirely, you will get an error. So in this case, because we matched it properly, IntelliJ is happy with that error, but it's still complaining here. And the thing is, when you're creating a method and you're defining parameters of a certain type and a name, you then don't have to create them in the method at all. So we can actually delete that. Because what actually happens is if you define these parameters, Java will automatically create variables with the appropriate data type for us, which is really nice, and they'll be deleted when the process goes back to the line after the calculate score. So in this case, I deleted those variables. So there's now a variable called game over, score, level completed, and bonus that have been created automatically by Java for us because we've defined those as parameters for our method. And now we've got no errors. So what we should be able to do is actually just run this code, and we should get the same result as we had with our code blocks. And you can see we've got exactly the same answer. So far so good. And we've cleaned up some of the code, but it's still a little bit messy. And the reason it's messy is we've still got this extra line here, and we've also got these variables. Well, let's change the second one by doing this. Calculate score, true again, because that's the first parameter. You notice as I'm typing, IntelliJ is highlighting which parameter you're up to when you're typing, which is really nice. It does that automatically. So the second parameter was 10,000. Third level was 8. And the fourth one was 200. So they're the 4 parameters, and they match up to the score, the level completed, and the bonus, which was the second statement that we're actually going to execute. But notice this time I'm actually typing the values in directly. I'm not using variables or anything like that. So consequently, what I can now do is delete that. Then I can actually delete these because we don't need them anymore. And now when I run, the first value is the same, but notice the second value has been fixed. Why has it been fixed? Well, we're calling the calculate score method. It's got the fix. So of course the second value has now got a score plus 1000 because it's correctly got the fix in there. You've noticed that we've only actually programmed this code once now. So there's only one place that we can make changes to it, and we can make one change, like we could change that final score to 2000, execute it, and both scores automatically get updated. That's because they're both using the same method, which is pretty cool. Now the other thing we could do here is, instead of putting half values and half variable names, I could actually finish this off and actually put 5 there, because that was level completed 5 and the bonus was 100. And I can make this even more efficient by deleting these variables, because of course we don't need them anymore. And we've now got a far more efficient looking bit of code. We've literally only got 2 lines that actually send information through to the method. And we run it, and we get the same result, but of course we've added the final score of 2000, which is why the values are higher. So that's one of the great features of methods, is that it makes it a lot easier for you to maintain your code, because we've only got one place now where our code is modified, one method. And also you notice that we cleaned up a lot of code. There was a lot of extra code we had in our main method. We're down literally to 2 lines. Now incidentally, there's nothing stopping us actually using the variables that way, the way that we had them before. Like for example, we could paste this in, and then we could change our arguments to put game over, score, level completed, bonus, like so. And also down here, we can do the second thing. We can put those new values there, delete this out, and put in that new call. So this is a good way of also creating code, because looking at this now, you can say, okay, this is the calculate score method. Game over must be in some sort of indicator as to whether there's game over. That's obviously the score we're sending through, the level completed, and the bonus. So you can see how that would make more sense from reading that. You get an understanding of what this particular method does for us. So you're free to use hard-coded numbers, literal values that I just had there previously, or you can define variables if you like and use the variable name. And what happens is, when the method is called, if you're using variable names as arguments, the case of game over, what happens is the calculate score method gets called, Boolean game over, it looks at the value of the game over, in this case it'll be set to true, and that's what the Boolean game over parameter gets set to, and of course that then matches with this in the method. So either way will actually work. Now that's pretty good in its own right, the fact that we can actually call a method and get it to do something and to make our code look a lot cleaner. But it does actually get even cooler than that, because what we can also do is we can get our method to do some calculations, much like it's doing now, but we can send back the result of that calculation or that processing, whatever we're doing, back to the code that it was executing that actually had called the method in the first place. So we can get the two of them to talk together. So we can calculate something and send the value back to the code that was actually calling the method in the first place. And it'd probably be easier if I show you rather than try and explain it anymore. So to do that, this makes use, returning a value it's called, makes use of this void keyword. So what void means is don't send any value back. So if you're creating a method and you don't want to return any information, you use the word void. Void means nothing, empty, don't return anything. But if we do want to return something, we need to change the word void to the type of data, the data type of the information that we want to send back. So in this case, let's actually return what the final score was, return that as a score that we can use back in this method here. So in other words, right here, when we call this calculate score method, we don't know what this calculation ends up being. We only see that it's displayed on the screen. But let's actually get that number that was calculated here returned back to us. So what we need to do is change this void first. We want to return some data that is of data type int. And immediately IntelliJ says you've got an error, and the error is that we've defined it as returning data, but we haven't actually told it to do that yet. So what we need to do is we need to add an additional line of code to tell it to return that information. So how do we do that? We come down here and we put return final score. What that actually does is it sends back the final score back to this part of the program. But the thing is, we've still got an error. So why have we got an error? Well, when you're sending some data back with a method, you've got to make sure, no matter what, that some value gets sent back. It's not okay to just, if game over is set to true, to return a value. We also have to send a value back even if game over isn't true. So in other words, all the program variations have to be accounted for, and we've got to return something every time if we specify that we are going to be returning data. So a quick challenge for you. How do you think we would change the code to return a -1 if game over was equal to false? Pause the video, see if you can figure that out, and come back and I'll show you how to do that. Okay, how did you go? There's two ways of doing that. We could actually put an else here, else, and we could just put return -1. That then removes the error. So you can see there's now no longer a problem as far as Java is concerned, because if game over is set to true, it's going to return something. Else, in other words, the else here is no matter what else happens, return a -1. So that's going to work. But we could also have done it this way. We could also put a return -1 here. So what happens there is the same deal here. The return gets executed here. As soon as the return keyword is hit, as soon as it processes that line, it doesn't go any further. It immediately goes back to wherever the call code was that actually called the method in the first place. So consequently, we'll only get to this line here if this previous line hadn't been executed, and therefore Java is happy that we've covered our bases and we've returned something no matter what the program flow was. Okay, this video is starting to drag on, so what I'm going to do now is pause this video and we'll continue on with methods in the next video.